Artificial intelligence, AI, is the field of computer science concerned with building systems that can perform tasks that would normally require human intelligence, such as visual perception, speech recognition, and decision-making. Machine learning, milliliter, is a subset of AI that deals with the design and development of algorithms that can learn from and make predictions or decisions based on data. Milliliter algorithms are trained using large amounts of data, allowing them to make predictions or decisions without being explicitly programmed to do so. This enables milliliter systems to automatically improve and adapt over time, becoming more accurate and effective as they learn from more data. There are three main types of milliliter: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, the algorithm is trained on labeled data, and uses this training data to make predictions about new, unseen data. In unsupervised learning, the algorithm is not given any labeled data and instead tries to identify patterns and relationships in the data on its own. Reinforcement learning is a type of milliliter where the algorithm learns from the outcomes of its actions and receives rewards or punishments to guide its decision-making. Milliliter has a wide range of applications, including image and speech recognition, natural language processing, fraud detection, and recommendation systems. It is being used in many industries, such as finance, healthcare, retail, and transportation, to make more informed decisions, improve operational efficiency, and enhance customer experiences. One of the biggest advantages of milliliter is its ability to scale and improve over time. Unlike traditional rule-based systems, milliliter algorithms can continuously learn and adapt, becoming more accurate and effective as they are exposed to more data. This ability to continuously improve is what sets milliliter apart from traditional programming, where the system must be updated manually to improve performance. Another advantage of milliliter is its ability to process large amounts of complex data, making it possible to identify patterns and relationships that would be difficult or impossible for a human to see. This can be particularly useful in areas such as healthcare, where milliliter algorithms can be used to analyze medical images and help diagnose diseases. However, milliliter also has some limitations and challenges that need to be considered. For example, milliliter algorithms are only as good as the data they are trained on, and they can be biased if the training data is biased. This can lead to incorrect predictions or decisions if the data is not representative of the real world. Another challenge with milliliter is interpretability. Unlike traditional rule-based systems, it can be difficult to understand how an milliliter algorithm arrived at a particular decision or prediction, which can make it difficult to trust the results. Finally, milliliter requires a significant investment in terms of data, computing power, and expertise, and it can be difficult for organizations to get started with milliliter without access to these resources. In conclusion, AI and milliliter are fields of computer science concerned with building systems that can perform tasks that would normally require human intelligence. Milliliter algorithms are trained on large amounts of data, allowing them to make predictions or decisions without being explicitly programmed to do so. Milliliter has a wide range of applications and offers several advantages, including its ability to scale and improve over time, and its ability to process large amounts of complex data. However, milliliter also has some limitations and challenges, such as the risk of bias, interpretability, and the need for significant investment in data, computing power, and expertise.